Okay guys, welcome back. So in this video I'm going to recap all the things that we talked about in class concerning making a graph of your data and then also finding equations. So if you follow along with your own data, you can pause this video whenever you need to and then just come back to it. So we're going to start by putting our headings here, and we'll call this the uncertainty in Y for the third heading. Remember that you can sort of double click in between to get auto spacing, and we're going to go up by 3 centimeters for X, but remember that we want this to be in the third quadrant, so we're going to put in -3, and we really want that to be -3.0 and -6 and so on. So I can apply a pattern to fill out the rest of this by dragging this down to 24, and I think I'm going to make the font a little bit larger so you don't have to squint at an overhead, but just to make it a little bit easier to see. So I will auto space the columns again. Okay, so these are values that I borrowed from section 3, okay? And these are also all negative, and you should be putting in whatever your values are. So notice that that last one I had put in 10.35 and it rounded it to 10.4. Same thing with that one and with that. There's two ways to fix this. One way is to make the column a little bit wider. The other thing is to select all of the data and right click and format the cells, and make sure that you tell Excel we want this to be a number with 2 decimal places. And move this up here where you can see it. So number and 2 decimal places. Okay, and then with these guys it's probably good enough to have 1 decimal place. And that's because you probably measured the X distance to 1 decimal. So for this you probably said it was plus or minus 1/10 of a centimeter. So there it is. Okay, and then the uncertainty, we'll put that in. Notice that every time I type in a 0.50, for example, it cuts it off. So we're going to fix that again by selecting the data, and we're going to format the cells, go to number, and for this we definitely want 2 sig figs. And I actually rounded one of our data points that I was given in class today just to make it a little bit easier. Okay, so we're going to make a graph, and we're going to graph X versus Y. So I'm going to select all of that data and go to Insert and a scatter plot like this. Okay, now we can do a couple things with this. One is we can make this chart area a little bit larger, and if you hold down the Shift key it'll force it to kind of grow with the same ratio. So there you go. And what we can do with this is, if you look up here at Chart Tools, you have to actually be clicked on the chart area to see this Chart Tools. If you're on the spreadsheet, you're not going to see it. So if you click on the chart somewhere, Chart Tools, we can go to Layout and we can give it a title and X versus Y. Alright, and we can go to the Layout and give it titles for the axis. So horizontal is X in centimeters. And we can actually take this little text box and move it so it's on the x-axis. And then we can do the same thing with the vertical one. Whoops, I don't want that format, sorry. So we could have also in centimeters and put that down here. Okay, now if you think that these points are too big, you can right click on them and format the data series, go to marker options, and then if you click built-in, you can change the type of point and you can actually change the size. If I wanted to, I could even pick a picture. So if you wanted little monkeys for your points, you could do that. Okay, so if I close this, now I have a little bit smaller points. You may not want them quite that small, but you get the idea. So now I want to add in a trend line, and my trend line is going to, well, let's see. Do we want to put a linear trend line on this? Oh, maybe. And if we display an r² value on the chart and the equation, we can look at the different options and see what we can do. We can't do an exponential because we have the point 0, 0. That's the same reason we can't do a power. Logarithmic, we can't do that because we have a 0 value. Okay, so we're going to have to try something else. And how about a polynomial? This is what we tried in class, and this is a polynomial of order 2, which is quadratic, so that's a parabola, and we're going to display the equation and the r² value. Okay, and just like earlier in the class, okay, we can't just leave this equation as it looks now. I'll make the font a little bit bigger. Okay, so what we need to do with this equation is think back to that one homework problem. So it was like this. If you had y is equal to ax² plus bx plus c, what are the units of a, b, and c? Well, we want y to be in centimeters, right? Because that's what we have on ours. Y is in centimeters. So what are the units of the 0.0283, the 0.0437, and the 0.1188? What units do those have to be? Well, x² is centimeters squared, so a, like in the problem, has to be 1 over centimeters. Likewise, x is in centimeters, and b has no units. And then c is going to be just centimeters. So b doesn't have any units, and this one is going to be like so. So we'll put in 1 over centimeters. Okay, let me sort of move that. There's more space. Now the b term doesn't have any units, and this has units of centimeters. Okay, so that's our first graph. Now we want to try to come up with 2 more graphs. We want x versus time, and we also want y versus time. So to do that, first we have to calculate time. I'm going to move this graph kind of out of the way. Okay, so like we talked about in class, we can calculate time, because if delta y is vy initial t plus 1/2 gt², for a horizontally launched projectile, vy initial is 0, so that means delta y is 1/2 gt², and now we do a little bit of algebra, so pause if this is a bit rough and figure it out. So we have 2 delta y over g. We could also just say that as delta y over negative 4.9. Okay, so then we go back to our spreadsheet, and again, pause if you need to. And let's see, I think we're here. So we're going to do SQRT is the square root, and we want the square root of y, but that's in centimeters, so we have to divide by 100 to get to meters, and divide that by negative 4.9, and that's going to give us the time. So take that and drag that down, and okay, that looks good. So now what we want to do is, remember, we always want to have time on the horizontal axis. So we want to graph x on the y-axis and time on the x-axis, and then we want to graph y on the y-axis and time on the x-axis. So those are the two graphs that we want to make, and it's kind of annoying to do that in Excel, but here's what we can do. We can take the x values and kind of copy those and paste them right here, and now this gives us a good way to select all that data. And I have my x values in the first column and my y values in the second, so I'll do a scatter plot, and there it is. Okay, now you should go ahead later on and put in the title, the axis, etc. All that I'm going to do right now is put in a trend line, and this is going to be a linear trend line, and I'm going to right click to format it because I want to see the equation. Okay, and now I can't really say that this equation is y equals, because that's not what I'm graphing. So I'm going to make the font a little bit larger, and you'll remember that what we're actually graphing on the y-axis is the x distance, and what we're actually graphing on the x-axis is the time. So that's one thing. The other thing is, I can't leave this equation without any slopes or any units. Okay, so the unit of the slope, negative 126.97, well, let me think about what I have here. Maybe it would help if we quickly put on the horizontal axis. The horizontal axis is time in seconds. Okay, and the vertical axis is going to be x in centimeters. So that means that the slope is going to be centimeters over seconds. And so if I go into here, I'm going to have centimeters per second. And the intercept is going to be, well, let's see, it's on the y-axis, so that's actually centimeters. Okay, and let's make this a little bit bigger. So there it is. This is our graph of x versus t, and I should probably give this a title above the chart and call this x versus t. Okay? Now, you know enough about graphs that you probably recognize the slope of this graph, negative 126.97 centimeters per second. Okay? You probably recognize that that's a speed, and you probably remember from class that we talked about the equation for delta x. Delta x equals Vx initial times t. Now remember, delta x can be written as x final minus x initial. Okay? So if I bring my x initial to the other side, then what we're saying is x final is equal to Vx initial times t plus x initial. And if we look at our equation, that's exactly what we have. We have x equals Vx initial times t plus x initial. Now we're only off by 0.03 of a centimeter. That's pretty good. That's probably just experimental error. Okay, so there's that graph. And it's very important when you're doing this that you put in all of that information. Okay? Now finally, let's make a graph of y versus time. And for this one, we're going to take the y values, and again I'm going to copy and paste them. But this time, when I select the data, I'm going to select my times, and I'm going to hold down my control key and select that second set of data. Now if I do this right, let's see. So that gives me a graph, or if you look on the x-axis, those are times, and if you look on the y-axis, those are actually y values. So this is what I want. Okay? I'm going to quickly put in some titles. Okay, so this is time in seconds, and the other axis is going to be y, which is centimeters. And I hope it's clear to you that this is not supposed to be a straight line, that this is supposed to be a parabola, and linear just isn't going to cut it. So we do a polynomial. Look how nice that fits. Display equation, display r squared, and let's close that bad boy up. Okay? And now when I go like this, okay, let's take a look at this equation down here. Alright. Again, I can't use x and y, can I? Well, I can use y, right? But can I use x? Nope. That's not what I'm graphing. I'm graphing time. Okay, so this one is also time. And I have an r squared of 1, which is pretty cool. And the reason that I have an r squared of 1 is that I used the y values to get the times. So I was kind of cheating. Okay. In any case, that's why you have a 1e negative 12. That's a decimal point and 12 zeros before you, or 11 zeros before you hit a 1. And the same thing with this. So basically these terms are 0, and I'm just going to go ahead and pretend like they're not there. If your terms are larger than that, well then you have to worry about it. Okay, what should I have for the units of this? So here's some more dimensional analysis, and if I have y equals 490 t squared, well, y has to be in centimeters and time has to be in seconds squared, so guess what this is? You guessed it, centimeters per second squared. Okay? And we already said that for our projectile, delta y equals Vy initial times time plus 1/2 g t squared. And we said that Vy initial was 0 because of the horizontal launch, and so we have delta y equals 1/2 negative 980 centimeters per second squared times t squared. And guess what? There's your 490. Okay? So our final equation here so I'll put a parentheses there, centimeters per second squared times t squared. And of course we'll put a title on this graph, and we'll call this y versus t, and there we go. So these three graphs are what you're going to print out and have ready for next class. So sorry this video is a little bit long, but hopefully it helps a little bit with the graphing.